Hey, welcome back to Fat Mama Physics. In this video, we are going to start off with looking at velocity time graphs. In fact, we are going to have to break up this lesson into 5 videos because there's a lot of stuff to go over. I know, I'm scaring you already, am I? Well, I mean, this is kind of like a little bit of a disguise here, but I'm actually going to also touch on acceleration time graphs. I'll do that very quickly, and there's not so much stuff that warrants a separate lesson, so I kind of just bunched it all together. But we do want to get through quite a bit of things because if you think about it, velocity time graphs are kind of the bridge between displacement and acceleration. So there's quite a bit of connection building to establish. So let's get to it. This video, for the first video, we are going to start off with uniform motion and just taking a simple position time graph and using it to draw a velocity time graph below. Notice I'm also using OneNote instead of my other application, so hopefully this will give us more flexibility and more things that we can do. Okay, so here we have this position time graph. The first thing you notice is that the velocity does change. And another thing too that I recommend you do when you get any sort of graph is to try to see if you can visualize the motion. So here we have this person. He starts off at the origin. He starts to move away in the negative direction. Let's just say he's moving backwards. He's moving backwards all the way to the negative 6 meter mark at a constant velocity. We know that because the slope is constant here. And then he suddenly starts to move back. He starts to move backwards past the origin and forward again at also a constant velocity, but in the forward direction. In fact, probably a little bit faster than what he did before because the slope is steeper. Then he paused at the 4 meter mark for about 2 seconds, and then he darted back again, and a little bit past the origin in the backwards direction. Okay, so let's first thing we want to do when we want to draw a velocity time graph is we need to know the velocities, right? And since the velocity changes, here I have a tip here is where you might want to break your graph into chunks where the velocity is the same. So let's do that. I'm going to change into a black pen here. So here I have a break here at the 3 second mark. He changes his velocity again here, and at the 7th second mark. On my velocity time graph, it's kind of over here, the 5, and the 7 here, okay? So I'm going to do, so first we have to find the average velocity for each of these chunks. I'm going to do chunks 1 and 2. I'm going to task you with doing chunks 3 and 4, okay? So let's do 1 and 2 as examples. And I'm going to change a pen. So the first one, to find the velocity on a position time graph, remember, we need to find the slope. Here the slope is constant. So we find this triangle here. So slope we know is rise over our run. And here we are descending. So we're going to have a negative rise. 1, 2, 3, 4, 5, 6, or just read the graph. Minus 6 meters. And over the run, which is 1, 2, 3 seconds. Okay, this gives us negative 2 meters per second for our first segment. Okay, now our second segment, I'm just going to do the calculations all at once and then draw it later, is I have now a second right triangle to deal with to find our slope. Okay, I'm going to do it up here. So here we have slope, and we know this rise over run, so I'm just going to get to it. Goes all the way from negative 6 to positive 4. Our rise is a whooping 10 meters over 1, 2 seconds. So careful, it's the difference, it's the run of the triangle. Be careful, don't use the whole 5 whooping seconds. That's incorrect, okay? Just your right triangle that you're dealing with. That gives us 5 meters per second, okay? So we got our 2 velocities. We can now graph the first 2 chunks on our velocity time graph. So first of all, we have a -2 meters per second. So all the way from 0 to 3 seconds, the velocity is constant, is not changing. It's going to remain at -2 meters per second. Just like that. Now notice, unlike our position time graph, we have a straight flat line instead of a diagonal because we're talking about the velocity, and the velocity is constant. It's the same throughout the whole time. And now our velocity jumps all the way up to positive 5 meters per second. So that's about there. And I'm just going to draw a straight line again for the 2 seconds because the velocity is not changing. And you might be wondering what happens in between these 2 lines. Now, I'm not going to draw a line connecting them because that would be very weird. And if you already know what that means, is we get some sort of an infinite acceleration, which doesn't make sense. But what you can do is you can, and I'll accept either one as your answer later, is you could leave it blank, or you could draw a dotted line between these 2. So it just shows the graph is kind of discontinuous in that sense. All right, so that's chunks 1 and 2. I now encourage you to try chunks 3 and 4. So it's a good time to pause, and after the pause, I will go over it. So here we have a slope of 0, so we get 0 meters per second for our average velocity. In the next segment, we have a negative slope, which we are descending by -5 meters over 1 second, giving -5 meters per second. Drawing this on the graph, we have 0 on the origin and -5, and then using dots to connect them. All right, so here we have the last 2 chunks. Aren't you lucky? You got to deal with a 0 slope. And there we go. We found the last 2 chunks over here. So quick recap on some important points. Good thing to visualize your motion of your graph. That way it gives you an idea. That will help you check your answers later. And number 2, always good to break down the graph into chunks to help you draw your velocity time graph. All right, so thank you for watching part 1 of your long lesson full of 5 videos in total, 1 out of 5. And I will see you in the next video, part 2.